Here in math script, we have a couple of components in evaluate an expression that are actually pretty interesting. What are these and what do they do? We've run into them several times, but we've never quite paid attention to them. Let's take, for example, a vector, point, and construct point. Now I'm going to plug in a slider into x. I'll make a slider that goes from 0 to 10. Our point is going to be moving from 0 to 10. But let's say that we wanted to use the same slider in y, but modify it a bit. Maybe we want to add something or we want to change the value. We could, of course, go to maths, operators, and use any of these simple addition or multiplication or division. But we actually have another option. In y, if we right click on that, you know that we have the modifiers for the inputs. And we have something here called expression. We can take that input from the slider and express it in some manner. For example, let's say that I want to make that twice as much. So I could say here, x times 2, x being the variable for the input. Any input will always be using the variable x. So here it's 5 times 2, and say commit changes. Now as I move my slider, here I have a point in 6, but in y, I have the value 12, because I've expressed that. Notice that the input gives us that little marking. Now let's right click on y again, go to expression. Notice we can actually go here to an expression editor. Let's click that. This expression designer shows us all sorts of different ways that we can write these expressions. This is a very simple expression. We could do x times 2, x plus 2, x minus 2, x divided by 2, etc. And all of these would be just fine. But we can even go further. And if we click here on the top right where it says Grasshopper Expression Functions, we have all sorts of functions that we could actually use here in this expression designer. We could round things, we could do things dealing with texts. There's a lot of options, and this is definitely more akin to scripting or programming. So let's say, okay, leave that there. Let's look at the expressions themselves. So I'll go to Math Script and Evaluate, Math Scripts, and Expression. They essentially are the same thing, but just in slightly different formats. Evaluate component actually was the original component, and you would plug in a function into the f, and x and y, and eventually you could add other inputs would be your variables. I prefer actually using this expression component because you can see the actual expression in here. Of course, if you zoom in, you can add more inputs. Let's just use one input for now, and what I'll do is I'll create a list of numbers. Let's go to Sets, Sequence, Series. Let's make this list a little bit different. Let's go to Params, Panel, and let's make the list increment by strange value. So here in a panel, double click on the canvas, quotations, I'll want it to increment by 1.5234, for example, something a little bit wackier. Let's say we wanted to round these values to the closest integer value. Well, what we could do is simply just go to params primitive, integer, we can pass the values through there, and now we'd get the rounded value. But let's say that we wanted to get, for example, the closest integer above it or the closest integer below it. Well, we could use an expression to set that up. I'll plug in my numbers into x. I don't need the y for now. I'm going to take this off. We'll get an error here because it's saying that it doesn't have a variable y because we've just deleted that. Let's double click here and let's say that I wanted to get the closest integer but below the roundings. What I could do here, I have a couple of functions that are, for example, floor or ceiling. And let's see what these do. So first I'll start with floor. I'm going to say floor of x. And let's look at the result. The rounding gives us this list of values and the floor gives us the next list. So here, for example, 1.523 was rounded up to 2 because it's bigger than 1.5. But in the case of the expressed value here with the floor function, this 1.5 is actually rounded down to 1 because it's rounded down to the closest integer below the value. Here, 13.7 naturally gets rounded up to 14 because it's bigger than 13.5, but in this case, it gets rounded down. Now you can imagine that if we use ceiling, we get a slightly different behavior. I'll say okay, I'll say, so here, what we're getting is 13.7 gets rounded up to 14 because it's the closest integer above the value. Those are just a couple of handy things you can do, and there's all sorts of stuff you can do inside of the expressions. Let's go back to our point here, vector, point, construct point. This time what I'll do is I'll plug in a sets, sequence, range into x and y. What I'll do is in D, I'll plug in pi. So I'll go to maths, utilities, and pi. And here in n, I'll put in, for example, 4. So we get something like that. What if I changed these values? So for example, here in y, I could right click, I could say expression, and I could say sine of x. Now we get a sine curve. I could increase the number of values, which then is going to increase the number of points. Here in n, for example, I could put in 100, put in, and I get more values. If I go into x, go to expression and say, for example, cosine of x, I'll get points around a circle. So you can see there's lots of things you can do in expressions, and sometimes it's better to do them in an expression, maybe if you just have a very simple modification of the value. But depending on what you're doing, I still do recommend using the components because, again, we want the Grasshopper definition to be as explicit as possible. I know with an expression, I actually do get this little signal here that's telling me that I have an expression, and then the value. Depending on your level and how comfortable you feel with expressions, you might really adopt them and really like them, or you might use them in certain situations where you have a simple modification of an input value.